Hey, Kat, we haven't yet talked about one of the largest sources of greenhouse gas emissions.
You must be talking about energy.
Yep, and specifically the energy it takes to produce heat and electricity.
Worldwide, that's something like a quarter of all emissions.
But there's a silver lining when it comes to the energy sector, particularly here in the US. I learned that from Alyssa Kendall. She's a professor of civil and environmental engineering here at UC Davis.
Our electricity sector is one of the sectors that we are actually decarbonizing, albeit not quickly enough. But we are able to replace fossil fuels with renewables. So we have replaced a lot of coal-fired power plants with natural gas-fired power plants. Natural gas still has a lot of greenhouse gas emissions, but per unit of energy generated, it's a lot less than coal.
And speaking of coal, this year, for the first time on record, the U.S. is now producing more electricity from renewable power than from coal.
That's right, electric utilities are retiring aging coal plants. And well, the pandemic has pushed coal production into a deep crisis with reduced electricity use and the economic downturn.
But that's good news for the climate, as coal is the dirtiest of all fossil fuels.
And even if coal makes a rebound, major utilities and technology companies are increasingly turning to renewables.
In part, that's because renewables are cheaper than coal.
Yeah, but there's a lot to unfold when looking at our energy future, and Alyssa is going to help explain it all in this brief bonus episode of Unfold.
Climate models all agree that temperatures are going to increase.
It's going to be hotter, it's going to be drier, fire's going to burn more frequently.
Maybe this is never going to be the way it was again.
We need to come up with ways to literally pull CO2 out of the atmosphere.
How are we going to work together to solve a challenge like climate change?
Coming to you from our closet studios as we shelter in place across the Sacramento region, this is Unfold, a UC Davis podcast that breaks down complicated problems and discusses solutions. This week, we unfold decarbonizing energy. I'm Amy Quinton.
And I'm Kat Curlin.
So, Kat, guess what the biggest problem is when trying to decarbonize the energy sector and rely more on renewables?
The fossil fuel industry lobby?
Likely, yes, but technically speaking, Alyssa says there's a big drawback to most renewable power right now.
The problem with electricity is that at a certain point it becomes very hard to get rid of our natural gas-fired power plants or our coal-fired power plants if they're still around, because we need some source of very reliable electricity.
Renewables like wind and solar aren't as reliable because, well, the sun doesn't shine all the time and the wind doesn't blow all the time. So we have this intermittent power conundrum.
Right. Important to point out here, though, that a UC Irvine study found that solar and wind could meet 80% of U.S. electricity demand. But like Alyssa said, it's that last little bit that is a giant hurdle and requires substantial investment.
But wait, Amy, aren't we finding ways to store energy from renewables so we don't have to worry about intermittent power? Like big batteries.
Well, that's what I thought, but while we can store renewable energy with batteries, it's not for as long as we might need. And Alyssa says when we start looking at storing it reliably for the grid for extended periods of time, let's say a few weeks of sunless skies, batteries aren't a great option.
If we think about investing large amounts of money and materials and which have environmental impacts of their own, if we think about investing all of those to build enough storage capacity to meet these sort of extended gaps in renewables, the economics don't pan out and the environmental impacts don't always pan out either, meaning we might be increasing environmental impacts by investing in a huge amount of battery storage.
So batteries have a big environmental impact then.
Lithium-ion batteries require lithium, obviously, but they also require heavy metals like cobalt and nickel.
And mining those materials can cause all sorts of pollution problems. We don't want to solve one problem by creating another.
It's interesting you said that because Alyssa mainly analyzes the full life cycle of products, technologies, and even policies. And she says it's really critical that we do this.
That makes sense, because if you think about this on a broader scale, we don't want to just reduce greenhouse gas emissions to fight global warming. We want to improve the environment for everyone.
Alyssa became interested in life cycle analysis when she was just a 22-year-old engineer working in the auto industry, and she worked on some of the very first electric vehicles on the market.
I also lived right near a coal-fired power plant in Michigan, and the vehicles we were designing at the time were not very efficient. And I kept thinking, are we really helping the environment? Like, at the time, most of us were a lot more concerned with air quality from vehicles than we were with climate change. But still, the question was, are we really doing better? So I thought I invented this new way of looking at the issue, right?
So like all good engineers, she went to work figuring it out.
I sat down to try to pencil out, like, well, what do the emissions really look like from this vehicle that we're designing? And in the conditions that we were operating in, the gasoline vehicle was much better.
Wait, what? She compared a gasoline car to an electric car and found the gas car was better for the environment?
Yeah, can you believe it? I mean, here is why. She was basing her research on the car operating in a cold climate, and cold climates make batteries less efficient. And electric vehicles also, of course, use electricity. And if your electricity comes from a coal-fired power plant and not renewables, then you get a dirty car.
So that's not to say that electric cars are bad for the environment. You just need to look at more than tailpipe emissions to think about how the car was made, what resources went into building it, and where your electricity sources are coming from. So yeah, the entire life cycle.
Right. It's fine to have an electric car in California because a lot of our electricity comes from renewables. But Alyssa says it's really important we look at the life cycle when examining climate change solutions too.
We want to make sure that when we're designing something new or trying to find a better solution, that we're not sort of causing impacts either in a different environmental category that is really important or up the supply chain somewhere else. So life cycle assessment is really important for climate change choices because we don't want to invest in something that seems like it has lower emissions but causes a whole lot of emissions somewhere else that we can't see.
Speaking of better solutions, did Alyssa talk about other renewable sources of energy that look as promising as wind and solar?
Well, we talked a little bit about tidal and wave energy, but there you have a ton of transmission issues. If you live near the coast, that might be okay. But other potential renewable sources that she talked about, one of them was green hydrogen, which is something I really hadn't heard much about before.
Yeah, what's green hydrogen? Is that like hydrogen fuel cells?
No, it's essentially sort of making hydrogen from renewables. She gave me one example in Northern Europe. Alyssa says there's a tremendous amount of wind power there off the ocean, but there isn't the transmission capacity to move it where the demand is.
So one of the innovations that's been pioneered, Germany has, I think, 2 sites that have done this, where they take that electricity, they split water, and they generate hydrogen. And they put the hydrogen into what has historically been natural gas lines. Usually they blend it with natural gas. But that decarbonizes the natural gas that they use a bit by blending in renewable hydrogen. It makes the natural gas a bit more energy dense, meaning per unit of gas there's more energy in there. And so they've been able to add some low carbon fuel essentially to their natural gas system because they have this excess wind capacity.
So plans are in the works here for a green hydrogen power plant. Los Angeles Power and Water wants to convert an old coal plant in Utah into a plant that runs on green hydrogen by 2045. It wouldn't be using excess wind power like they are in Europe, but they'd slowly convert natural gas to hydrogen.
It sounds like it's going to take some innovative solutions to get us to 100% renewable power.
Yeah, and it's going to take more than that to combat climate change. I asked Alyssa how hopeful she was that we can find solutions.
In terms of optimism, I do think if you'd asked me 10 years ago, I would have just said, we need to mitigate, meaning we need to reduce emissions. We still need to do that. But I actually think we need sort of a moonshot initiative in terms of solutions. And that means we have to worry about adaptation, meaning how are we going to help people who are going to be displaced or from where they live or where they grow their food. But we also need to come up with like carbon negative technologies now. That means we need to come up with ways to literally pull CO2 out of the atmosphere. And if we don't do that, we're not going to get where we need to be.
So we really need technologies to sequester carbon. Easy.
Right. Well, you know, Alyssa is an engineer. So of course we can come up with carbon negative technologies. She actually was pretty hopeful about it all.
You can find out more about Alyssa Kendall and renewable energy at our website, ucdavis.edu/unfold. I'm Kat Curlin.
And I'm Amy Quinton. Thanks for listening. Unfold is a production of UC Davis. It's produced by Cody Drabble. Original music for Unfold comes from UC Davis alumnus Damian Verrett and Curtis Jerome Haynes.